MCA prep packet, day number 8. Benchmark 8411. Collect, display, and interpret data using scatter plots. Use the shape of the scatter plot to informally estimate a line of best fit and determine an equation for the line. Use appropriate titles, labels, and units. Know how to use graphing technology to display scatter plots and corresponding lines of best fit. Henry collected the following data during a car wash fundraiser. Cars, 6, 11, 16, 21. Minutes, 26, 47, 69, and 90. Part A. Enter the data into your calculator. For the resulting scatter plot, what is the equation of the line of best fit? We don't have the capability on our MCAs to enter this data into your calculator, so we're going to draw the scatter plot and then find an equation for a line of best fit. So for the x-axis, we'll put cars. So for my cars, I'm going to go by 5s. And then on my y-axis, I'm going to do minutes, and I'm going to go by 10s. So I'm just graphing these ordered pairs. And they look pretty linear. So when I draw my line of best fit, I'm going to adjust it a little bit to make sure that it's a good representation. Okay, so my line of best fit goes through my data. You can tell that it's a positive correlation because it's going uphill. And for my line of best fit, I am going to say my intercept looks like it's at about -10. And my slope seems like it's going up about 10, 20, 30, we'll say about 36 if that point was at, so it's going up about 36 over 6, so about 6 it looks like. So it looks like it's going up about 6 over 1. If I had graph paper, if I graphed this on graph paper, you could get a more accurate line of best fit and a more accurate equation, but I'm not too worried about on this estimate. Now titles, I've got cars and I've got minutes for my axis labels, and it says it was a car wash fundraiser, So a title for this graph could just be car wash fundraiser. So this would be a good enough title. So car wash fundraiser, the number of cars, and the number of minutes. 8412. Use a line of best fit to make statements about approximate rate of change and to make predictions about values not in the original data set. This benchmark, to me, is more important than the last one. This one is about using the line of best fit to make some approximations, to make some predictions about your data. So number one, the scatter plot shows the number of minutes needed to cook a number of hamburgers. Part A, what is the approximate rate at which the hamburgers can be cooked? So the rate, so I'm going to pick this point right here. It looks like it's right where the grid lines intersect, and I'm going to pick this point right here. So I would be rising from 30, so 10, 20, 30, 40, 50. So my rise is 50. And then the run, if I look at my scale, this is 10. So that would only be from 5 to 10. So that would be 5 hamburgers and then another 5. So 10 total. So 50 divided by 10 is 5. So the rate I've got is 5. So 5 minutes per hamburger. So be careful with your axis labels and make sure that you are not just counting grid lines, but you're looking at what those grid lines represent, because the scale was different in each direction on this problem. About how long did it take to cook 10 hamburgers? Now if I go to where 10 hamburgers is, then I go up to the line of best fit, it's right here. So it looks like it's between 50 and 60. So I would say this spot to me looks like about 55 minutes. Eight, 4, 1, 3. Assess the reasonableness of predictions by using scatter plots by interpreting them in the original context. So reasonableness. So if this is reasonable. Edgar's mother measured Edgar's height every 6 months for 5 years. The table below shows the measurements. Make a scatter plot of the data. Okay, so a scatter plot of this data. We've got dates, so I'm going to put the date here, and then we've got heights. So I'll put the height over here on the y-axis, and the height is in inches. Okay, so I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different dates. So 104. And then 604. 105, 605, and so on. And then the heights, for these heights, I'm going to put a little gap in my graph because I don't want to start at 0 necessarily. I'm going to start at 40. And just go by 5s. Okay. So I have the first height is 41 inches. My next height is 42, so it should be just a little bit above it.
Please excuse the interruption. All 6th grade students with the last name of A through H who plan on getting their picture taken today and have money for them, please go down to the stage area. If you are planning on having your spring picture today, please go down to the stage area if you're in 6th grade A through H.
So I'm just graphing all of these points. Okay, so after graphing them, I should, let's see what we need to do. We make a scatter plot, and we don't have to do a line of best fit on this one. It just says, for part B, Edgar predicted that he would grow to be 70 inches by June of 2010. Do you think Edgar's prediction is reasonable? And explain. So I guess that if you think about this, his height obviously is increasing, but the question is 70 inches a reasonable height? That's what you need to think about. How many feet tall is 70 inches? Well, if 12 inches are in a foot, then 12 inches is 1 foot. You could keep on going, and maybe you know this, so multiplying by 5, 60 inches is 5 feet. So 72 inches is 6 feet tall. So 70 inches could very well be a reasonable height for him, because it isn't 7 or 8 or 9 feet tall. 70 inches by June of 2010 seems like it could be reasonable for him. It depends on how tall his parents are, and it probably depends on his age, because it doesn't tell us how old he is, and obviously at a certain point everyone does stop growing. So I, in my opinion, would say that it is reasonable. If they had said something like 80 inches or 90 inches, maybe not so reasonable. You should be finished with the entire packet now. Good luck on your MCAs.